So in this video we'll just look at example 15 on page 219, looking at axis of symmetry, turning points, etc. So the question asks us, find the equation of the axis of symmetry for y equals x squared minus 6x minus 2. So let's work through what they've got here. Y equals x squared minus 6x minus 1, minus 1, not minus 2, has an a value of 1, so the coefficient of x squared was 1, and a b value of negative 6. Substitute into the formula that we were using before, x equals negative b on 2a. So x equals negative 6 on 2 times 1, and work that out. Negative, you got a negative at the front here and the negative there, two negatives make the positive, and so you end up with 6 on 2, which equals 3. State the result. The equation of the axis of symmetry is x equals 3. So, the important thing here is in the question, it actually asks you for the equation of the axis of symmetry. You have to actually write x equals 3. You can't just say it's 3 or something, or you have to write the equation is x equals 3. Actually write some words to go with your numbers and letters there. Anyway, moving on to part B. The coordinates of the turning point. So coordinates, plural, meaning there's two of them, and it also says point, so make sure you write your answer, some x value and some y value in brackets. So here we go, find f of 3. So they've taken their original equation here, y equals 3, y equals, the original equation is here. Always good to write the original equation first. But in this case you might write f of x equals x squared minus 6x minus 1, and then your next line of working might be f of 3 equals 3 squared. Sometimes it's good to put the brackets in where you're substituting things so you remember. And it's easier to show multiplication by putting things in brackets rather than writing it this way. It kind of makes the equation fall apart visually, but this still holds the same sort of visual form as the original equation. So anyway, working through that, they've just got their answer there, but just for good measure let's work it out. So 3 squared is 9, minus 3 times 6 is 18, minus 1, which equals 9 minus 19, which is negative 10. Cool. And that's what they've got, and they've actually again said state the result, and here they've written the coordinates of the turning point are, they've written it as a point, 3, negative 10. You could also write turning point equals 3, negative 10 if you're rushing and you don't want to write so many words. Now C, they want us to find the minimum value of the quadratic function. So remember, well, let's look at our equation, y equals x squared minus 6 minus 1. So our a value, our x squared coefficient, is positive. So positive is a happy quadratic, smiley face quadratic, because it's positive. So that means it has a minimum value here, and the minimum value is at the vertex or at the turning point. So where's the minimum value? It's the minimum y. How far down the y-axis it goes. So there's our x and y-axes. How far down the y-axis does that value go? So, well, you can probably guess the minimum value is the y-coordinate of the turning point. And that's what they say here. State the result. Notice that since a equals 1, a is greater than 0, so the function will be concave upwards and have a minimum value. The minimum value of the function is negative 10. Cool. In that case, shorthand answer would be min equals negative 10. And that'll do.